We're good. We're live. All right. So now we are going to talk about a fun little word called stoichiometry. All right? It's pretty fun to say. Stoichiometry. Zoom that in right there. Stoichiometry. Essentially, stoichiometry lets you, it's like how to control the product of the reactions, right? It's you can sort of use everything we've learned in the past in balancing equations, and we know, and we can sort of figure out our reaction, right? The product of our reaction. It gives us the product of the reaction. That's just a little context. And these are really quick. It's 2 steps to this, right? And step 1, to stoichiometry, to like everything in chemistry, step 1 is to simply balance the equation. You guys have been balancing equations for like what, a month and a half now? So you should be pretty good at this. So let's go ahead and just start off with an example real quick. You guys can write this down too if you want to. Example, follow along. Example. We have CH4 plus, we have O2, and that gives us CO2 plus H2O. All right, CH4 plus O2 gives us CO2 plus H2O. First of all, does anybody remember what type of reaction this is? Can anybody tell me? Starts with a C. What type of reaction is it? Not covalent. It is a combustion reaction. You guys remember it like that, this kind of thing, like single replacement, combustion, synthesis? This is a combustion reaction because the products are CO2 and H2O. Okay, let's go ahead and balance this real quick, right? Look at our C's, right? We have 1 C here, 1 C there. We look good. H's, we have 4 H's here, but only 2 right there. So let's go ahead and put a 2 right here. So now we have 4 H's on this side, but now we have 2 O's. And we only have 2 O's over here, so that seems good at first, but we have another 2 O's. So we have 4 O's on this side, and only 2 right here. We're going to need a 2, and the rest looks good. That seems balanced. That seems nice. Our step 2 is to simply solve the rest of the problem. Solve the problem. Right? It's like how to draw an owl. Draw a circle and then draw the rest of the owl. Right? Okay, so problems in stoichiometry are going to look something like this. So say, how many moles of water could be produced using 3 moles of CH4. That's a mouthful. How many moles of water could be produced using 3 moles of CH4? Let's look right here. 3 moles of CH4. In our balanced equation, we only have 1, right? So if we want to make it 3, let's just go We got 3. We have 3 moles now of CH4. So 3 is to 1 as, we need to find water, all right? 3 is to 1 as x. Go ahead and just write an x. We'll do some algebra. 3 is to 1 as x is to 2. 3 is to 1 as x is to 2. What's going to be our value of x? Well, we can sort of just look at this and know that 3 is 3 times larger than 1. So what's 3 times larger than 2? 6, right? We just multiply and we get 6, right? So our answer would be 3CH4 gives us 6H2O. Does that make sense? You guys see that right there? 3CH4 gives us 6H2O. That's very basics, the beginning of stoichiometry. We just want to use the mole to calculate the other moles, right? You use the mole to find the product of the reaction. Let's do one more example, and I'll pass out a worksheet that we can all do together. All right. Let's set up this. Let's set up this one right here. Let's go lithium plus magnesium oxide goes to 2 oxide plus magnesium. And that's actually going to be precipitate. Okay. We are asked for how many moles of magnesium will precipitate. How many moles of magnesium will precipitate? That because right there. How many moles of magnesium will precipitate in the solution if 3 moles of Li are used? How many moles of magnesium will precipitate in the solution if 3 moles of lithium are used? First, step 1, we got to balance the equation. Let's do that real quick. We have 1 lithium here and 2 lithium there. So we got to write a 2 right here to balance that out. Okay, that's good. Now let's look at our magnesium. We have 1 here, 1 here, 1 oxygen, 1 oxygen. Very simply, 2, 1, 1, 1. Now, we just solved this problem. How many moles of magnesium will precipitate in the solution if 3 moles of lithium are used? So we want to use 3 instead of 2. And we're looking for the magnesium, right? That's where we want to land. X marks the spot. So 3 is to 2 as what is to 1? Okay? 3 is to 2 as what is to 1? Well, 3 over 2 is just 1.5, right? That'd be the same. So with every 3 moles of lithium, so 3 Li, you would get 1.5 magnesium. And that's just that. Let's actually do one more example problem real quick, and then we'll do the worksheet. Let's do something a little bit more difficult. All right, let's set this up. Plus. Aha! A lot going on there. Okay. What is our problem? If 4 moles, let's actually balance this first. Okay, I'm gonna need some help with this. We have 3 lithium here. Let's look over here. White shirt at the front, where do we put? We put a 3 right here. Okay, that balances out. Now let's see, that messes up our chlorine, because we have 2 right here and we have 3 over there. So how do we balance out the 2 and the 3? Yeah, we're gonna have to get it to 6. So we're gonna have to put a 3 right here, and we're gonna have to change this to 6, which means we have to come all the way back over here, change that to 2. How do you look at that? That just messed up our calcium, right? We have 3 calcium now. Oh, but that fits. And now we have 2 phosphates, but that fits. Cool. 2, 3, 6, 1. That's how we balance this equation. We have, if 4 moles of calcium chloride are used, how many moles of LiCl will we get? If 4 moles of CaCl2 are used, how many moles of LiCl will we get? It's a little bit trickier, but there's a good way to do this. So 4 instead of 3. How many LiCl? We'll throw an X. I'm actually going to bring this down here. We have 4 over 3, and we want it to do the same as X over 6. We want those to be equal. We want those to make each other happen. What do? Multiply by the denominator, right? 6 times 4 is equal to 24. That divided by 3, that's a terrible 3, divided by 3 is equal to X. You guys see that? 24 divided by 3 is equal to X. That's how we do that. That means our X is going to equal 8. So we can write that as 4 CaCl2 gives us 8 LiCl. Okay, we're going to pass out a worksheet now. For those of you that are at home, is the worksheet available?
Yeah, it will be posted.
Yeah, the worksheet will be posted, so go ahead and try that after you watch this video.